Hello, welcome to question 5 of our physics exam preparation series. In this presentation, we'll be interacting with non-conservative forces. Right, so have a look at the question. Right, so 5.1, we're asked to define a non-conservative force. Again, straightforward 2-mark question, and we define it like this. A non-conservative force is such that the work done by the force in moving an object depends on the path taken, right? So that is very important in terms of getting the 2 marks. The keywords: the work done by the force in moving an object, okay, depends on the path taken. Okay, so it is dependent on path, not independent on path. Okay, what are examples of non-conservative forces? Applied force, tension, even frictional force. All right, so those are examples of non-conservative forces. So this takes care of 5.1. Let us go to 5.2. All right, we are asked to draw a free body diagram for the block as it moves up the incline. Okay, the applied force is parallel to the surface. We're not going to change that. That is the applied force. Definitely there is weight, okay, or gravitational force. Normal force won't be obviously vertically up because it's an inclined surface. It will be perpendicular to the surface all the time. That is the normal force. And again, parallel to the surface, we have friction, right? So there is friction. 4 forces for 4 marks, and that is usually the case, guys. If you want full marks, ensure that the number of forces correlates with the number of vectors or forces that you've indicated on your free body diagram. Okay, good stuff. Let's go to 5.3. Right, so 5.3, we are asked to calculate the total work done by the non-conservative force as it moves up the incline from point A to point B. This equation is in your formula sheet, and you just need to know how it works and what to substitute, okay? This equation tells us that the total work done by a non-conservative force is the sum of the changing kinetic energy and the changing potential energy. All right, so how can we do that? We have half m vf square minus vi square, that is for the changing kinetic energy, final minus initial, plus mgh, that is the equation for potential energy by the change, mg, so we need final height minus initial height. That is the change we're looking for there. Let me just correct this part here. Square must just be inside the brackets. Okay, good. So now we substitute f half. What is the mass of the block? It's 12. And the final velocity is 2.25 square minus 0 square. Okay, plus 12, gravitational acceleration is 9.8. The final height is 4.5, starts from the ground, so initial height is 0. Good. So guys, plug that into a calculator and you should get 559.58 joules. Okay, good stuff. Let us go to the last question under question 5 now. Have a look. Right, so now we are told that the block is moving at constant velocity from B to C, and there's a relationship between the frictional force from B to C with the frictional force from A to B. This one, I'm going to call it F2, is F1 plus 42 newtons, and this one is just F1. That is the original frictional force from our free body diagram there. So that is just the mathematical expressions that we'll make use of. The word or words constant velocity implies that the acceleration is zero. So in our F net equal to ma equation, this would mean that the net force acting on the block is also zero. Okay, so 0 newtons there. All right, so the total work done by the non-conservative forces, which is the applied force and the frictional force, it's expressed like this. Okay, so what do we know? If we expand this, it's F changing x cos of what? 0 degrees, because it is in the same direction as the direction of motion, the displacement, plus frictional force changing x cos of what? 180 degrees. Why? Because friction and direction of motion, they are in opposite direction. Okay, so this guy comes in there. So we have 559.58 equal to what? We have changing x there. So that is a 1, and it will just be 1 times this, which is f times changing x, and that will be a -1 there times that, giving us a negative fr changing x. So we'll have f minus fr, like that. Okay, so what are we told? That there is a constant velocity implying that acceleration is 0, the net force is 0. So when you subtract these two forces from B to C, okay, this F minus the frictional force, what must we get? 42, right? Because the frictional force here is 42 newtons larger than the original frictional force. So that will be 559.58. And if you do that, you'll get that changing x is equal to 13.32 meters. All right. So this takes care of question 5.4, guys, and the entire question 5 therefore. All right. So we are now jumping onto question 6 in the next video. See you there.